Hello everyone, welcome back. This week we're going to continue to talk about objects, except this time we're going to look into how we can create our own custom objects. Now we already know a little bit about making our own objects because we've been doing that in many of the examples using the curly brackets and then creating variables that contain many attributes. These are objects. But we're going to explore a little bit more of the syntax today. We're going to look at a concept called classes. With classes, what we're going to be able to do is kind of combine variables and functions into one template, one kind of bundle, and then from that template, we're going to be able to create instances of that class. So just like last week, we looked at the image object, the sound object, and the string object. Those are all represented by a class, and then when we create objects, we're kind of using that template to build these structures in our code that have both data and also functionality associated with them. Okay? So this is a little bit abstract, but we're gonna start with a basic example with revisiting our moving, bouncing ball circle idea. We're gonna explore the syntax using that, and then we're gonna do one more example this week, a little bit more fleshed out. So let's just dive into it. So before we can talk about classes and what that means, let's start by writing something that's going to use what we already know. Okay. So I'm going to define here a variable, and we're going to create it in setup as a simple object as we know it. And this is the syntax we use, remember? So we use the curly brackets, and then inside here we can define, what are the attributes of a ball object. So perhaps it has a X position, a Y position, and a speed. Okay, so this is something we've done already, so we're not going to explain that again. Oops, these should be commas, and something I always mix up, speed Y, and let's say a diameter, okay, for this example. So we've defined an object that has a number of properties, and then in draw, we can use that object to do stuff. For example, maybe we're going to set a white fill, and then we're going to draw a circle using the object's X and Y coordinate and also its diameter value. And then we're going to animate it. Okay, so we're going to add its speed to its position. Further, let me make sure that runs. So we have our moving object, and we're also going to implement our simple like bouncing behavior, right? So if we reach the edges, and we can tell by looking at the X coordinate, then we take the speed of the object, and we change its sign. Okay, we're going to multiply it by -1. I think we've also made it equal to minus the speed. Okay, it's the same thing. If you take a number multiplied by -1, you'll just revert the sign. Okay? And we'll do the same with the Y coordinate. So this is something we've already done, but now we have a little program that we can use to talk about classes. Okay? So in this simple object syntax, what we've achieved is we've created one variable that contains 5, right? So we've bundled our variables together as an object. What we're going to introduce now is a bit of syntax called classes. Now, classes are basically, I like to think of them as templates or blueprints. Okay, so if you imagine, just to do kind of a lame analogy, pretend you're a developer, right? And you're building a bunch of houses in your neighborhood. Your plans for the houses, your blueprints, are going to be your classes in programming. So they're not the actual thing itself, it's just the plan for it, right? Just the template. And then once you go out and actually build the neighborhood, you go out and create the objects, the houses on the street. These are going to be your actual instances, your actual object variables, right? So your class is going to be your blueprint. And then from that blueprint, you're going to create instances of that class. You're going to create actual objects. Okay? And every instance might be slightly different, right? For example, to go back to the house on the street analogy, maybe every house has a different address, right? They have a different number on the door. Maybe they have some variations in colors and materials, but they all are made from the same basic blueprint. Okay? So let's look at what this syntax, how this syntax works inside JavaScript. So to create these templates or blueprints or classes, we're going to use the class keyword. So this is a new keyword we haven't used before. We're going to say class, then we're going to give our template a name. And in this case, I'm going to call it ball because we're programming this little ball object here. Now notice I'm using an uppercase B here on purpose. This is just kind of out of habit. There's kind of this implicit convention in programming that class names are uppercase. Okay? So there's no rule, there's no hard rule that says you have to do that, but usually the instances will be all lowercase. So this is going to be my variable that I'm going to use to create my ball object. That's going to be lowercase. And then the name of the template is uppercase. This way it's easy to tell the two apart. And again, this is not a rule that you have to follow, but it's good habit. So I always name my classes with uppercase letters. So we say class ball uppercase, and then we use the curly brackets, right? Always have the same role. They define a section of our code. So inside these curly brackets, this is where I'm going to start to define the template for my ball object. Now the first thing we're going to put into the class is something called a constructor. Okay, so the constructor is a little function that's going to always run when we create instances from our template. So it's kind of like the setup for our object. And it always has the same name, right? So in JavaScript, the constructor is always going to be called constructor. And inside here, we're going to initialize variables in our object. So much like what we're doing over here when we create an object using this syntax, okay, we're going to do something similar inside the constructor. It's just going to look a little bit different. So I'm going to comment this out here. And in setup, we are now going to use this syntax. We're going to say ball equals new ball. Okay, so ball is my variable, okay, lowercase, just so we don't get confused here. And then this new keyword is also going to be associated with objects and classes. So we're going to say new. That means look at our ball template, uppercase B, and then give me a new instance, an actual object using that template. And when we do this, we're calling this constructor. Okay. So in the constructor, we're going to define the attributes of our object. We just have to change this. We have to use a bit of a different syntax. So we're still going to give our object an x, a y, a speed x, a speed y, and a diameter, except we're not going to use this syntax here with the colon. Instead, in the constructor, we have to use the keyword this. Okay, so this is part of the class syntax. So we're going to say this dot x, right, equals, let's say, random width. This dot y equals random height. This dot speed x, and then I'm going to do some copy and paste here because this is going to take a while. This dot speed x equals, right? We're going to say this dot speed y. And the keyword this, you can think of it as it sort of refers to the object's own internal variables. So when we're writing code inside a class or inside a template, we're kind of writing code from the internal perspective of the object. So now we're talking about variables that will belong to objects that are going to be created from this class. So this bit of syntax here achieves the same outcome as this over here. We've created a ball variable that's going to have these 5 attributes, and we just have to use a little bit of different spelling to write it out. And now if I hit play, my program is still going to work, okay, even though I commented this out. So we'll just delete this bit now. Okay. So on the surface, things are the same. Under the hood, though, we're starting to shift the way that we're structuring the program. And this is really what this is about, this example. We could achieve everything that we're going to do this week with what we know already, right? With the basic object syntax, writing functions. What classes are is just another tool that you have under your belt to structure your code. Okay? Just like functions help us structure our code and kind of organize our ideas, classes also have the same goal, the same purpose. So it's just another option that you have when you're thinking about how am I going to structure my program, how am I going to achieve the goals that I want to do in this little piece of code. And the more you can organize your code, the easier it's going to be to articulate your ideas. So in the case of classes, what they allow us to do is to start to think of our program as a collection of objects that interact with each other. And this paradigm. It's called object-oriented programming. It's not the only paradigm. There's other ones. There's another popular one is functional programming, where you only rely on functions and variables. But in object-oriented programming, it does have some advantages in terms of conceptually thinking about what your code needs to do. Because we are used to thinking of the world in terms of stuff and objects and things, we kind of have to just translate this thinking into our program space. So here we're building a program where we have a bouncing ball. So we're going to represent the ball as an object. Okay? So it's a modeling tool that will help us organize our ideas and kind of scaffold our code in a way that will make it easier to kind of express and articulate what we want to do with our program. So not the only way, but it's a very common way, and it can be very useful. So now we've created the constructor, okay, and we have a bunch of attributes for our object. Okay? Now notice the constructor is a function. Okay, so and what happens when I say new ball is we're basically calling the constructor, which means we have an opportunity here to insert some parameters to that constructor. Why would we want to do that? Well, maybe down the road, we might want to create multiple ball objects, and we might want to be able to specify what their coordinates are. Okay, so maybe instead of making it random here, I might want to add some parameters. So for example, we're going to add 2 parameters to our constructor. Okay, we're going to say the first parameter is going to be called the x and the y. And the reason I'm using these funny names here instead of just x and y is because this is already defined here, okay, as x and y. So, well, actually, we're using this dot x. So let's try it out with x and y, and let's see what happens. So we're going to say, instead of random width, we're going to say x and y. Okay? And then in setup here, we're going to pass some values to the constructor. So here I'm going to put it in the center of the window instead of random. Okay, so that works. So I guess I didn't need these funny names. So this is the reason you might want to give different names, though, is just to avoid getting confused. So now we have a variable called x and y, a parameter called x, sorry, and a parameter called y. So these 2 values are whatever we put in here when we create our object. Okay? Whereas this dot x and this dot y refers to the object's internal attributes, internal variables. Okay? So if you don't want to get confused between them, that's why one strategy some people like to do is just give different names, okay, so that we don't have a chance to get them mixed up. Now it's a little bit clearer that the parameters, right, the x and the y, go into a different place. They go into the object's internal variables, even though we do have the keyword this over there. So not totally necessary, but it can be helpful to make sure to help you kind of distinguish between the parameter and the object's own variable. So we've added some parameters, which means now we can create instances of our class, and we can decide when we create the ball object which starting location we want to give it. And its speed and diameter will remain fixed in this case. Okay? We could also add a parameter for diameter. Why not? Okay, let's say, and now I'm taking whatever the parameter number 3 is going to be. That's going to become the diameter of my object. And now I can set it here when I create my new ball object. So, and of course we could change this value, and this will affect the diameter of the circle. All right, so far, not much a big advantage to using classes. All we've done is kind of shifted things around and shifted the syntax by which we create this variable that has some attributes inside of it. Where things become a lot more interesting with classes is that not only do we have a constructor, we can also have any number of functions, which in the context of a class, we talked about that last week, they're called methods. Okay, so function, methods, synonym. Methods are functions that are inside a class. Okay? So this is just the correct technical term. So what does that mean to add functions to our class? Well, it means we can add things that our object can do. So for example, this is the code that is moving our circle. We might want to create in our class, we're going to write a move function. Okay? So we're kind of, you can, and Okay, so when we're in a class, we don't need to put in the keyword function. Sorry. So we just put the name of the function, so we don't put in the keyword. My bad. And this allows us to essentially define like behaviors that our object is going to have. So I could take this code here that is moving my object around, and we could move it into the class. Okay. Now we have to be a little bit careful here because I just don't want to copy and paste this. I need to go and change how we're going to write this code. So now it doesn't make sense to refer to ball, right, which is a global variable up here, because we're writing a template, right? We could have 100 ball variables. So here we're going to use the keyword this again. So instead of referring to a specific variable, we're just going to write this. Okay? And that's going to mean we are writing kind of a blueprint, right, for what it means to be a ball object in this program. And every ball object is going to follow the same template. So they're going to say, take your position and add your speed to it, and then take your speed, right, and reverse it when you reach the edges. Okay? So this is a lot more kind of generic, and we're just saying whenever you're a ball object, these are the things you're going to have. You're going to have these 5 variables, and by the way, you also get this cool behavior where you can move. Okay? Now, of course, we've put that into a function, so we have to actually call that function in order for this code to run, because I've taken this out of draw. Right? So now I have the ability to say ball.move. Right? So just like we can have attributes, right, variables inside our class, we can have functions. So now we have both. We have variables, and then we can also write some code that's going to use these variables to do things. In this case, it's a simple program, so my circle is moving, right? So I can tell it to move. Okay, so move. Same thing, we could say, okay, this is the drawing code for my circle, right? Let's take that out of draw and let's create a special function called draw. And again, I don't have to use the word draw here. I could use any word, but I'm just going to use draw again. Same name as this one. Not ideal, but it's straightforward. Oops, let's put that code into a function called draw. And now when we want to draw a circle object, we are going to say draw a circle at that object's coordinate using that object's diameter. And now if I want this circle to appear, I have to say ball.draw. Right? So pretty neat. So what we've done here is we've created a template, right? We've said if you want to create a ball in this program, what you can do is create a new ball object, and you have to give it a few starting parameters because we've defined 3 parameters in the constructor. But then once we do that, right, the constructor is going to go and take care of creating all the internal variables for us. So it's creating these 5 internal variables. And then on top of it, we've added 2 functions to the class, which means our ball has some abilities, right? We can use the dot syntax here to say ball.draw and ball.move. So this runs this code that we put into draw on this object. Right? So it's going to use whatever that object's internal variables are, and it's going to run that code. So this is a really powerful way to start to organize what your program is doing. You can kind of bundle functionality and data together into these kind of singular conceptual units. Right? This is a bouncing ball. I'm going to represent it as a class. And then in my code, right, in draw, things become very, very straightforward. Right now, what this program is doing is very easy to tell. It's clearing the background, then it's drawing a ball, and it's moving the ball. Okay, so the other benefit, kind of implied benefit to that as well, is now we can start to, just like with functions, we can kind of give labels to this code. We can describe it with words, right? We can say these 4 lines of code, this is what moves my object, and these 2 lines of code, this is what draws my object. So that in our actual program up here, now we're operating at what's called a higher level of abstraction. Right? So now that we have this, we've kind of taken the code that is a little messier here, and we've tucked it away into these functional blocks. And now we can kind of build on that. For example, we could say only move if mouse is pressed. Okay, just as an example, right? Oh, wow, this is slow. Let's try again. Oh, sorry about that, spam call. Only move if the mouse is pressed, right? For example. So now we can start to build more interesting things in this program using the functions we created in our class, and we're kind of operating at a higher level. We don't have to worry about how it's getting drawn or how it's moving. We've already programmed that. Now we know that we just have an object and we can tell it to do its thing. And then that in turn can kind of fit into more complex structures. Okay. So, all right, let's finish this example here by talking about the other benefit of taking the time to write a template, which is we can create multiple instances of this class, right? So if all we did was write a program with a single moving ball, this would be a bit overkill in terms of structure, right, that we would want to put into it. But let's say we want to have this same program, but we want to have, again, we're going to just create multiples, right? We want to have 100 or 50 or whatever, 2,000, it doesn't matter. We can keep creating new instances of the ball object from this template. Okay? So we're going to replace here this single variable. We're going to create an array, and we're going to call it balls, because I'm going to put an S because it's an array. That's something I like to do, so I remember that these variables that are written in the plural form represent multiples. Okay? And in setup, we're going to let the for loop, help us with repetition here. Let's create 50 objects. Oops, didn't mean to. Okay, we're going to repeat this 50 times, and of course, each time we are going to a different index into our array, and then we're going to create a new ball object. Now, just to make it interesting, we might want to also, maybe this time, let's create a different x coordinate. Okay, for each of them, we're going to map the counter. We're going to map it to a number between, I don't know, 100 and width minus 100. So instead of making it random, I'm just going to spread them out in line. Just why not, for fun. And okay. So that's going to go ahead and create 100 ball objects for me, right? Each time I'm using my template again and just kind of cranking out more of these objects. And then in draw, we're going to write the shorthand syntax. We're going to say for ball, right? We're going to go through all the ones that we have, and each time we're going to take these individual these individual objects, and we're going to tell them to draw themselves and then move themselves. So now we start with a bunch of objects in a row, which we did up here, right? And we have this little behavior here, which is they're not going to move unless my mouse is pressed, right? So if I hold the mouse down, then they move around, and if my mouse is not pressed, my code is still drawing them, but it's not running the move code, so they kind of freeze. Okay. And just to just really drive the point home that these are individual objects from the same template, we're going to add one more parameter to this ball object. We're going to call this an ID. Okay, and the ID is simply going to be as we create them, we are going to pass in the loop counter, our variable I here. We're going to pass that into the object's constructor so that we remember that this, the first one will get ID 0 and the last one will get ID 49. Okay, so we remember when we create them what value the counter had, and we're going to pass this in here as a parameter, right? So that comes through as the fourth parameter, and we're going to save it into this variable called ID. Okay, and then with that variable, we could do something like, once we've drawn the circle, maybe we'll set a black fill, and we'll set the text align to center, and then we're going to draw this ID value at our coordinate. Okay? And I have a syntax error. I forgot a Y. Okay, so now I have my number in here. Let's make it a little bit bigger too. Oops. Size 40. Or actually, we should make this a fraction of diameter, right? In case we change the sizes of the circles. So now we can see that, each of these circles, right? They're all built from the same template, but they each have their own variables, right? So in this case, when I first create them, right, I'm passing whatever the value of I was in here, right? So as this repeat, right, we create more and more circles. So now each circle kind of remembers what their index is in the array that we're storing them, just as an extra variable in there in the circle. So now this is now we can have like a lottery or something, right? Okay, so just to recap, and then we're going to do one more example this week, kind of going through this class syntax. With classes, we can write templates for objects, right? Blueprints. Classes are always going to start with a this bit of syntax, class. We give it a name. This is the name of our template. We use the curly brackets. Always be careful, again, to match your curly brackets. And then we have a few ingredients in there. We have a constructor. The constructor is the function that's going to run when we order new instances from our template using the new keyword, right? So this calls our constructor. And what that does, it says, okay, go to the factory and produce an actual object using that blueprint. And that object is going to run this bit of code. This doesn't have to only be, by the way, code where you're creating variables. You can run any code in here in the constructor, but most of the time we're going to be initializing variables of the object. Okay, so this is kind of creating the starting conditions for our object, defining these 6 attributes. And then on top of that, with the functions or the methods, technical term, we can add some code that's going to operate on these variables and bundle it together in our template. So in other words, we can give our object behaviors. So here I'm letting my ball draw itself, and also I'm letting it move by giving it these 2 behaviors that I've defined here as functions. The only kind of distinctive thing about these functions inside a class in JavaScript is that we omit the function keyword. Okay, so when we use the function keyword is to define these kind of just standalone, global functions that are not necessarily part of a template. When we're inside a class, we don't put in the keyword function. We just go straight to the name, but otherwise they behave the same, which means some of them could return values, right? Just like we talked about a couple weeks ago in functions. They could also have parameters if we wanted to. We're going to give examples of that maybe in the next video. But in this case, there's no need to have parameters coming through, so we don't put any. All right, so we're going to wrap this video up for now. I'm going to do one more example this week where we're going to run through this whole thing again, just building a different, a variation, a different kind of object, just to get some practice on the syntax. So I'll see you in the next video.